MIT में पढ़कर हम चलते हैं सक्सेस की ओर। MIT Group of Academic and Research Institutions, Aurangabad, Maharashtra, announces admission in engineering and management with 40 years in technical education, over 12,000 plus students, best placement cell in world-class companies, best infrastructure. Bead Bypass, Aurangabad. Call 0240-237-5375 or visit www.mit.asia.
A very good morning. I, Dr. Vinod Puri Gosavi, extend a warm welcome to all of you for a day 3 session 1 of International Technical Symposium on Opportunities and Challenges in Industry 4.0, organized by Industrie Sales and Department of Electronics and Telecommunication Engineering of Maharashtra Institute of Technology, Aurangabad, Maharashtra, India. It's our proud privilege to have guest Dr. Thomas Uslander. He is a research manager at Fraunhofer, IOSB, Karlsruhe, Germany. He holds degree in computer science from the University of Karlsruhe, Germany, and PhD in engineering of the Karlsruhe Institute of Technology, Germany. He is currently working as head of the department, Information Management and Production Control, and speaker of the business unit, Automation and Digitalization at Fraunhofer IOSB. He works on a various national, international IOSB projects as a leader in association with German environmental state agencies. His research interests is in analysis and design of open geospatial service architectures, a reference model for industrial Internet of Things, especially Industry 4.0 and environmental risk management. He is a member of expert panel of the Standardization Council Industry 4.0, that is SAI 4.0. He is advisory board for Digital Italy 2016. He got various awards like Object Management Group Application Award 2000 in the category of Best Application Utilizing Reusable Components, Dean Innovation Award 2017, Reference Model of Industry 4.0 Service Architecture, that is RMSA. He got a Best Paper Award in various national international conferences. He is a member of program committees in several international conferences, that is IoT Enabling Technological Track of CCNC 2019. So we're having such an eminent speaker with us. So not a wasting a single moment, I would like to request Dr. Thomas to start the session. His talk is on IT perspectives upon smart factories, Industry 4.0, and the connected world. So I would like to request Dr. Thomas. Dr. Thomas, over to you. Thank you very much.
Okay, thank you very much, Dr. Gosavi, for this nice introduction and a warm welcome to everybody in the audience. And yes, I would like to give you some insights into what is going on in Germany in Industry 4.0. And I've prepared a presentation of about 30 minutes. So I will close this because it's yes, now better for me to see the whole screen. Yes, okay, so I will talk not about the application aspects or the business aspects of Industry 4.0. I will focus on the perspectives of the information technology, so the IT perspective, because this is our main competence, and this is also the level where most of the activities are on at the moment. And one specific aspect I will focus on is the so-called connected world. So the connection between the enterprises in a production ecosystem. Okay. Yes, so the content of my presentation is, after a short introduction into our institute, IOSB, I will talk about the motivation, the standards, the architecture, the use cases, and the engineering aspects of Industry 4.0, with a final consideration of takeaway messages and some insights into reading materials. So first of all, who is Fraunhofer? Fraunhofer is a society. It's Europe's largest organization for applied research, and applied research means we are bringing basic research results into use. So we do technology transfer. And what is important to know is that there are many Fraunhofer institutes. There are over 70 institutes. They are spread all over Germany, and we are covering more or less all scientific disciplines. So I am focusing on the information and communication technology, of course, but we are also member with our institute in the production alliance, and we are also active in the security environment. So what does applied research mean? It tells you, okay, what is our mission, our message. So I already told we are trying to bring results of basic research that is coming from universities, from Max Planck Society, from Helmholtz, from Leibniz, into practical and usable results. But another aspect is where does the money come from? And one important message here is that we are just getting 25 to 30% of our budget from the German government. Most of the budget, as you can see, is then to be gained from the market. This means we are a research organization, but we are thinking like an enterprise, like a company, and we have to look after the market. So there are 27 institutes and more than 26,000 employees. So we are a big player. You see here Professor Bayer on the right-hand side. He is the managing director of our institute of Optronics, System Technologies and Image Exploitation, IOSB. And what does it stand for? We are dealing with all the optronical aspects. So where does the information come from? By means of mainly optical sensors. So we are trying to understand the physics of optical sensors and how does the information from the environment comes into an IT system by means of such sensors. Once the information is within the computer environment, okay, you want to get information out, and we are focusing here on image exploitation. We are trying to think about how to get meaning out of images and videos and image sequences, and this is, if possible, in an automatic way or at least in a semi-automatic way, and using interactive means with the users. My personal competence field is more on system technologies. So we are one of the few institutes at Fraunhofer that is trying to understand the whole life cycle of complete IT systems. So from the analysis of user requirements over the design and conception of system architectures up to the development of components and their deployments in real-world environments. Our focus here is always on open systems, on open architectures. That means we are trying to map the requirements to open standards in order also to foster interoperability. So IOSB has 700 scientists and engineers. We have a budget of around 60 million euros and so on. In Germany, we are spread over 5 locations. My personal location here is Karlsruhe, which is in the southwest of Germany, so close to the French border. There is my department, and there are the business units in which I'm involved. You see here we have many departments, so I do not want to go into detail here. All their competences are brought together in so-called business units, and I'm spokesperson of one of the business units, which is the automation and digitalization business unit. You see it here on this slide. So together with my colleague Olaf Sauer, we are managing this business unit, automation and digitalization. So this is the core of the talk, the main aspects of this business unit. And it is for many years now influenced a lot by the German initiative Industrie 4.0. I will come to the explanation of this term later. This is one driver, one influencer of our work on real-time IT for complex industrial processes. Another one is how to share data and how to share data in a controlled manner with defined usage control policies. So we are also active in the German and International Data Spaces Association, which is about data ecosystem based upon standards. Standards, okay, we are using mainly 2 of them. One is the OPC-UA communication architecture of the OPC Foundation. The other one is Automation ML, the automation modeling language, which is mostly focusing in the engineering domain, how to exchange data between engineering tools. And OPC-UA is more focusing on interacting with real assets in the physical world. One interesting trend in this overall environment is how to bring the real world together with the virtual world. And here the concept of digital twins is becoming more and more prominent. Digital twins are also discussed in the Industrial Internet Consortium, and we are also active here in this international consortium. What is very important is this aspect of interoperability. And interoperability in the past has always focused on the real world, how to allow production assets, production machines to interact, to communicate, to exchange data in a very efficient way, such that you don't have to reprogram all direct interfaces. But now with the emergence of digital twins, interoperability is now also very important in the virtual world. So interoperability aspects are across the real and the virtual world, and also for digital twin ecosystems. This is one of the key aspects for future production ecosystems. There are trends, as I already told you, in production environment towards integration of the virtual world. So we also have extended our original automation focus of this business unit via automation and digitalization. So we are covering now production IT, which is also called operational technology in some literature. So OT with enterprise IT. So this OT-IT integration is very important, and this is also one of the focus focal aspects of the platform Industry 4.0. So these are the market trends to bring this together. And if you look at the Gartner Hype Cycle of 2018, you already see that IoT platforms, so Internet of Things platforms, are becoming very, very important. They will be a kind of commodity in 2 years or in 3 years. That is now, this is the decisive time to think about, okay, what type of IoT platform do I use also for the production environment to bring IT and OT together? Because on the market there will be a consolidation phase, and after 2 years, then maybe just a few of them will have survived, and you have to sit now on the right track in order to be one of those who can benefit from those platform functionalities that have the most market coverage. So this is the market trend. The technology trend is that such IoT platforms should be open, should be based on open standards. So this is one of the technological objectives of Industry 4.0, to hinder big IT players around the world to dominate the production environment. We do not want to have the Amazon, the Google, the Apple, the Alibaba for the production environment. We want to have an ecosystems of many of such platforms. So they should be there, of course, but they should interact also with smaller IoT platforms in Germany, in India, in Tokyo, in Asia in general, in the US. So we need an ecosystem, and this is only possible based on industrial environments. So we also have to adapt, of course, our own systems on the market, where we learn from the practice. So this is, for example, our production control system Provis, that is used at the car manufacturer Daimler, Mercedes in Germany, but also in the steel industry at ThyssenKrupp. We have a process monitoring environment and system that allows to apply machine learning algorithms to condition monitoring in the process industry. And also in glass sheet drawing, we are active at Heraeus in Germany and USA. So all these running systems, of course, have to undergo also now a migrational phase versus open IoT platforms. We have international corporations in this business unit, as you see, of course, also in Germany and in Europe. There are a lot of corporations with Spain, Italy, France, and so on. We have contacts and projects in the US, in Canada, in Asia. We are connected to the Japanese Industry 4.0 like initiatives such as the RRI, the Robot Revolution Initiative, and the Industrial Value Chain Initiative. We are connected to Korean research centers such as KT, and we have a close collaboration also with India, with the well-known company Calisito. We are cooperating with them on in the domain of communication systems, in the domain of OPC UA. Such international collaborations also mean collaboration within initiatives around the world. You see here a lot of initiatives and standardization organizations such as the IIC, the International Data Spaces Association already mentioned, the Open Geospatial Consortium, the OPC Foundation, and so on. So we are active in all of them. Now coming to Industry 4.0. Sorry. This number 4 is not a version number. It should indicate the advent of the 4th industrial revolution. And in fact, it indicates a new stage of organization and control of the whole value chain. This is important of many assets across their entire product life cycle. Sorry. And the core driver for this is the internet. So in the past, the industrial revolutions were driven forward by energy supply systems, such as steam engines, such as electricity, and in the 17th of the last century, it was microelectronics that drove forward the industrial revolution. Now, this is the communication via the internet, the possibilities that we have. So up to now, optimization in industrial production has been mainly targeting the aspects of optimization of matter use, energy costs, energy use, and personal costs, things like that, to bring down the costs of production, to increase quality, to optimize the production. However, the full potential of the data that is stemming from all the machines turning into information and knowledge, this potential is still widely unexploited. And with Industry 4.0, we can change this because we get a lot of data via open interfaces, and then we can plug in new and modern machine learning and artificial intelligence algorithms in order to improve the decision taking and to support the decision makers and the humans in the production environment. Industry 4.0 covers mainly 4 value chains. One is, of course, the production itself, but including the after-sale services. So if you have produced your product, maybe a car, but also maybe some machine for the households, it's not forgotten. You have to offer also after-sale services. So you surround the products with services and offer them to your end users. So there is a feedback also possible from the end users, and you can offer them new services. Now Volkswagen in Germany has started to sell its new electric car ID.3. However, the software is not yet quite ready. So some of those after-sale services will not be able to be offered to the customer, but they can do that in future update cycles. Also, Tesla is doing it like this. So this is now a new approach how to support the customer, which was not possible before. Industry 4.0 also covers the development phase of products and product lines, and also the development of the associated product plans, and also supports, of course, the operation of the technical plants. There is this so-called platform, Industry 4.0. So this is not a technical platform, but an organizational platform driven forward by the 2 ministries of Economic Affairs and Research. And you see here a lot of icons of Fraunhofer. Fraunhofer in general is active in the steering body, and Fraunhofer IOSB is active in various subgroups and research supporting groups, in standardization groups, and there I'm also active. So what are the challenges? They are how to define an open architecture, which type of standards should be used, and what are the use cases, and how to engineer such environments. So the challenges to be solved is mainly to turn this well-known automation pyramid into such a service network. Service network that allows to interconnect all the assets in a production environment based upon open standards. And what are the challenges? Okay, to do that in an interoperable way. not to lose security, how to do it in a dependable way with low latency. If you are close to the shop floor and to real time environments, then you need low latency communication. We need to plug in machine learning and data analytics, and not to forget, there is still the challenge to integrate the human into such a service network. So it's not that we want to have human-less, human-free production environment. The human has its role. For example, in the assembly process, it's not to fully automate the production environment, but to do it in an optimized way. So this is an evolution on technological level, but it is a revolution on the business level. So there will be disruptive effects on the business level, which we should not forget. If you miss the right time to jump on such IoT platforms, maybe you're one of those who cannot recover this because others are building their business model upon the availability of data from such IoT platforms, and then you cannot be in this market again. So what are the biggest challenges? Here it's very clear it is missing interoperability and also the fear to lose security in such service networks. You may have seen already this three-dimensional box of Industry 4.0 on the left-hand side. So this is the well-known reference architecture model Industry 4.0, the RAMI 4.0. There are various introductions and presentations about that, and you will get here these slides, and then you see there are also YouTube videos that explain this reference model architecture. It's about three dimensions. There are the architectural aspects. This is this vertical dimension. What is important is this dimension here. This is the life cycle dimension. So for all these asset types, we are considering their engineering phase, which is this type field in the life cycle dimension. And there is, once the asset has been produced or is under production, then we are in the instance field of the life cycle dimension. So this is very important to look not only at production itself, but also at the engineering. And at the moment, if you're looking into the companies, there is a big gap, at least on the IT side, between the engineering departments and the production departments. The asset dimension covers all the asset types of the production environment, of the automation pyramid of the production environment, that is the field device, control device, and so on, up to the enterprise level. So this is the ISA pyramid, which is quite common. However, two asset types are added, which are very important. One is the product itself. So the product is considered to be an asset in the production environment, as we consider a control station to be an asset and a machine. So this is very important to understand. And also the connected world, that is the interconnection between the production enterprises. So all the logistics and so on, this is also considered to be an asset type. So on the conceptual level, this seems to be quite easy and understandable. But what is the challenge is we want to have, for all these asset types, now a uniform representation in this virtual world that I considered in the beginning. And this uniform representation is done with this well-known asset administration shell, or simply administration shell. So it's a kind of logical coverage of physical assets. So like a shell, that's also why it is called like this, a shell around physical assets, whereby these assets may also be virtual. So consider of documentation or of a model or a simulator of a machine, which would be in the engineering phase. Then you would also like to access these assets via the same interface, via this interface of the Industry 4.0 component. So this is very important to understand here. So one common interface, maybe with various asset type specific information model, but one interface across all these asset types. Here you see it again in a bigger slide. So the I4.0 component is a software component with a well-defined I4.0 standard interface for communication. This may be OPC UA, but this is not the only way to communicate. There are also RESTful interfaces. There are also MQTT and publish-subscribe interfaces to this component. So you have here then descriptive data of an asset, which is also called for the computer scientists metadata. And of course, you have management software. Standards. If you want to know more about the asset administration shell, just go to the publications of the platform Industry 4.0. There is this specification of the details of the asset administration shell. And then you can download that. You have here the link to that. In the meantime, there's a new version. So this is an old slide. We have now a new version of by end of 2019. Of course, conceptual architectures that do not help in interoperability. They are just a starting point. So at the end of the day, you must bring it down to concrete technologies. Here you see the recommendations of Industry 4.0. And it's quite clear that for the engineering phase, for this type field of the life cycle dimension, we have automation ML. But for the production environment, OPC UA is being recommended in its two forms, both as a client server communication paradigm, request reply interactions, but also publish subscribe, so event driven processing, complex event processing. This is also possible via OPC UA. So this is mainly recommended for the production environment. And what is important here is not only how to communicate, but also what to communicate. So the OPC UA information models, they are very important. There's also a possibility to bridge these two recommended standards. One, as I said, is automation ML. It's an IEC standard. It describes what to communicate, and there is OPC UA. It's another IEC standard, 26541. It provides communication service for communication, configuration, and runtime data delivery. And there is a mapping possible between these information models. So you can also map information models here from this left-hand side in the engineering phase to information models of OPC UA. Use cases. Here, I want to focus on one of the very advanced use cases, which is the smart factory web of Fraunhofer IOSB. This is a platform for sustainable and resilient production ecosystems. It's an IAC testbed, and you may use this platform to build marketplaces for industrial production. In order to respond to the following demands, in modern production environments, you need higher resilience of your supply networks, for example. You need to know, okay, which of these deliveries are possible, even if there are disruptions in the supply network, maybe based on such crisis that we have currently in the world with the corona virus. But there may be also other causes of disruptions and breaks of delivery networks, for example, natural catastrophes or political unrests or whatever. So we need more resilience here. Sustainability is one of the aspects. How to assure that for example, the ecological requirements of some country are being followed also by all those countries that are delivering materials for an end product. We need to assure this for the whole supply network. Then, what is very important, higher flexibility. You need to adapt the production environment not only on factory level, but also on supply chain level. So it should be very easy to switch between several supply chains. And this in the context of a higher product variance. So there are more variants to be produced for one individual product as in the past. Manufacturing on demand. So there's a request from a customer. Okay, I need 10,000 instances of this product type. By when can you produce this? So you need very quick answers in order to be successful on the market. And smaller lot sizes, and customers want to have individualized products. So these are all the demands from the market, and we see that there are effects and consequences not only on the factory level, but also on the supply chain level. And that is why with our Smart Factory Web, we can build such marketplaces to increase the flexibility in such production ecosystems. So it's manufacturing as a service, but also more and more logistics as a service. So this is the idea of this marketplace. You have here your factories. You register the capabilities, so what you're capable to do in your factory, drilling, boring, doing laser cutting and things like this. You're describing this as capabilities in such marketplaces, but also the production assets. So all what I have written down on the slide about the reference architecture model Industry 4.0. So once this is being registered in the platform, there are customer requests. They may search for capabilities and assets, and it's the role of the platform to make matchmaking between the customer requests and the capabilities of the factories. Once you have found a candidate factory, you forward the request, the order to that factory. In order to do the real production, maybe you have to adapt the production environment. So we need efficient means to do that. So we need secure plug and work of assets. And then at the end of the day, you can offer new business models by means of such a platform on the market. The benefit for the factory owners is they have immediate visibility on the global market, and they can offer manufacturing as a service. So this portal, this Smart Factory Web, offers manufacturing as a service to customers, and the various business models possible. Either this is just a broker, and then at the end of the day, there is a bilateral relationship between the customer and the factory, or the platform itself offers the production as a capability and taking over all the warranties for production and the quality criteria to ensure all the quality criteria, then this platform gets a real high responsibility. You have similar market-driven platform economies in other branches. For example, the tourism industry. You can simply replace here these factories by hotels and restaurants and pensions and so on. They register their offers in the market portal, and the end user, the citizen, and those who want to travel just register here, and they can search for hotels and then book them directly. So we want just to transfer this business idea, this business model concept to a production environment, but in a way that all these interactions are based on open standards. More and more we see that you cannot simply register here the tier 1. You also have to consider the whole supply chains and all the delivery factories into the marketplace. As I said, we need more flexibility on the factory level, but also on the supply chain level. Industry 4.0 covers this idea in 4 application scenarios. There are literature on this in the platform Industry 4.0. I do not want to go into that, but just focus at the end of my presentation on another research aspect. Once you have such an open architecture, then you need also to consider how to engineer production systems based on such an open architecture, based on such IoT platforms. So here you have the problem to bring together 2 different views. One view of the thematic expert, of the production engineer, of the mechanical engineer, of the electrical engineer, and of the business engineer. So there are business IT strategies that express the view of the thematic experts. On the other side, there are the computer scientists, and they express their views. They are talking about architecture, services, interfaces, REST or OPC-UA, automation ML, and so on. So all these expressions and terms and concepts, they are not understandable by the thematic expert. So there's a gap between the requirements expressed by the end users and the intermediate users and the capabilities expressed by the IT experts. And we need methodology how to bring together these 2 views and to make this gap smaller. We have a method to do that, which is called SERVUS, and it allows you to do this systematically. Because at the end of the day, you have to think that we have to go one step further as it is today. Today, we think about product engineering and plant engineering. In the future world, as we have already seen, the products are surrounded by services. They have to be plugged into service platforms where there is already basic functionality. So we also need service engineering, and all this has to be consistent. It makes no sense to deliver the product without the services in these today's worlds, and the services need to be interoperable with other services, but they of course also need to be synchronized with the products and the assets here in the production environment. Version management is of course an issue here. If you are updating your service in your iPhone or in your smartphone in general, then of course it has to be tailored to the hardware that is underneath. So the IT companies, they master this. They know how to do this. But think about the car manufacturers and the other manufacturing of classical products. They also need to act now like an IT service provider, which is a quite big challenge. And here, this Industry 4.0 component may be a very important conceptual asset because it allows you to do this in an interoperable way based on open standards. At the end of the day, the operation should be secure and dependable. As I said, there is a methodology to do this, which is called SERVUS. So the user requirements, how does it work? The user requirements are expressed in terms of small user stories. We are then systematically analyzing these user stories and turn them into more IT-oriented use cases. So here, functional aspects are described, the actors have been identified, workflows have been identified. So based on this, we can then systematically derive functional and non-functional requirements from such use cases. But that's not the end, because this would be a classical top-down approach. If you are in the world of IoT platforms, then you also have to think from the bottom up, what are the existing and the future technologies? Think, for example, of time-sensitive networking in a production environment and real-time environments. This will be a future technology. So we have to abstract from them, defining capabilities of your production environment, so existing and future capabilities. And now the big challenge is, okay, how to map this? Is there a possible way to map all the requirements to the capabilities, to the existing and the future ones? Then you're fine, because then you have considered all the requirements coming from the use cases. So you, based on your platform and their capabilities, you can solve all the requirements from the use cases, or if there are gaps, you can identify them. Also on this level, such abstract capabilities may be realized by one or several technologies. So also the question here is, are there missing mappings, or are there may also be multiple mappings, and you have to decide which of the technologies and in which combination are best. So you could do this just on paper, but better is to do this in an information system. And we have such a system, and this is called a platform engineering information system. With such a system, you can then, in an agile manner, develop your system. You can start entering the user stories and the use cases and derive from them the capabilities. So I think this is very important to have such a platform engineering information system. Here you see the dashboard for it, some examples, how to enter into the system, how to search then for use cases, user stories, requirements, and so on. And you see all the links between these concepts and artifacts. So what are the takeaway messages? And I come to the end of my presentation. As I already said, there is a turn towards exploitation of the potential of data, information, and knowledge in industrial production. I think, and this is my deep conviction, that you need also you need to understand the openness of such platform architectures, and also the availability of the associated service engineering methodologies if you want to really do that. So a data scientist, okay, he may get some data from the production environment and then get out some very interesting results. However, if you don't manage as a company to turn this into running applications based upon platforms and open architectures, then I think you're lost, and you need for this an engineering methodology. So that would be my takeaway message. You will get all the slides, and so there are also some interesting reading material that you may access. And that is what I wanted to bring you over as a message. And I thank you for your attendance. And I'm looking forward to a small discussion now directly after this presentation, or also later on in the panel. Thank you very much.
Thank you, Dr. Uslander. There are some questions from the participants. So I'll ask the questions from the participant side. The first question is from Prajakta Dasharde. Is it possible to use .NET for implementing digitization?
Of course. So .NET is a Microsoft technology. If you have followed the movement of Microsoft in the last 5 years, you see they are more and more open towards open source software. And they are also very active in the platform Industrie 4.0. And they have an OPC UA interface, for example, for their cloud environment, for the Microsoft Azure environment. Yes, .NET, maybe not yet now, but it will support OPC UA. OPC UA originally also came from a Windows environment supporting .NET and how was it called? DCOM environments, distributed communication. So that was the original. It was Windows fixed, Windows proprietary, but now it turned it into an open process control unified architecture, which has nothing to do anymore with Microsoft technology, but it will be offered in Microsoft environments, and Microsoft also has OPC UA interfaces.
Sir, second question is from Abhishek Sau. How can Industry 4.0 help in circular economy implementation?
Thank you very much. Very good question. As I showed you, and you still see, I think, my presentation. Yes, circular economy means more and more you have to consider also the supply chains. You have to know first, where does the material and the subcomponents come from? And what is the material characteristics of the subcomponents, because this is then very important information that you can put into such information models of the asset administration shell for this product assets. So it would go in here, and you do not lose this information across the entire life cycle. So at the end of the day, once it comes to recycling and to reuse, you still know, okay, what are the characteristics of my product? What are the subcomponents? What are the material characteristics? Then you can then instrument your sorting systems and also configure your recycling environments. I hope this answers your question.
Thanks, sir. Next question is from Zuman Barniwala. Sir, will all existing industries will have to transform into IIoT framework to be compatible for new technologies?
Probably yes. I think this trend is something that will not be broken. If you look at the Gartner hype cycle here, you see it was already promised 2018 that there will be such IoT platforms as a commodity starting from 2023. Okay, this market will be consolidated in this time frame until 2028, meaning that if you don't use the capabilities of such platforms, you are an outsider. What is important is that these platforms are open and based upon standards. At least we in Europe, we do not want to do this all on the basis of big IT giant players coming from Asia or from the US or even from India. They should all be interoperable. We should still have space for small and medium-sized companies and also for startups to plug in their solutions in an open manner into such an ecosystem.
Next question is, so how much time you think Industry 4.0 will be prominent in a developing country like India?
Okay. Of course, from a German perspective, we would love to have India to be one of the cooperation partners for the platform Industry 4.0. That is that you have the same trends. There are same market trends. And the question is, would you respond in India with the same technologies and the same type of interfaces and the same type of architectures? The platform Industry 4.0 started in Germany, but wants to become a global trend. So we are active now in international standardization. We are working very closely with Japan and China and also the US, and we would also love to cooperate with India. So welcome to such an initiative. Welcome to join such architectural models and open communication systems. And I think also for India, although you are a very, very large market for yourself, you need to obey the international technological trends. And here you may rely upon an architectural work that has now already a history of 6-7 years. So please do not reinvent the wheel, as we say, but to try to reuse it and to bring it forward such that we have on a global scale an interoperable ecosystem. That would be my wish, and India is welcome to join these international corporations and welcome to support the standardization of Industry 4.0.
Okay, thank you, sir. The next question is from Prashant Pandit. So what should be the criteria for selecting any production house to be converted into smart web?
So if I understand well, the question is there support for migration from legacy systems into Industry 4.0 open systems? Yes. I would say again, sorry for repeating myself, but this is the core concept. You may consider your legacy system to be simply an asset here. So this asset may be a legacy field device, a legacy station or work center, or it may be a whole legacy enterprise if you want. So the simple approach is to define such a shell, such an abstraction around this legacy environment, and to define the new information models here, focusing on the legacy assets, and then to internally map that into the legacy environment. Then you have a standard interface to your legacy system, and you still can run your legacy environment as long as you want, and step by step then replace the legacy assets by new assets that directly offer the I4.0 interfaces, such that the mapping here in between is getting more efficient and smaller.
Okay. Thank you, sir. The next question is from Brimalini Gadekar. So what are the database sources for survey data of Industry 4.0 readiness assessment?
For the readiness assessment, okay. This is maybe one of the key questions, of course. Is it just paperwork, or are there already products out in the market that rely upon Industry 4.0 interfaces? We have to admit that most of the results currently are specifications. And they are all accessible on the platform Industry 4.0 website, available in English versions. There are German versions and English versions. On that platform website, you will not find references to products because, as I showed you, the platform Industry 4.0 is neutral. So it's led by the German government at the end of the day. So we do not, it's not allowed to make advertisement for products. But of course, this platform is not just yet formed by research partners as Fraunhofer, but also by industry. So all members of the German production industry, all stakeholders are present. Siemens, Bosch, Festo, ABB. I do not want to tell you all this long list of well-known companies, but they are all involved. And they are all more and more turning their products into Industry 4.0 compliant products. This is a migration process. And of course, then also these German partners, they are partners in the platform, they are competitors on the market. You go to the websites of these companies and ask for Industry 4.0 compliant products. And this would then give you some readiness index of Industry 4.0.
Thank you, sir. So this is a question from Mohammed Ali. How will Industry 4 will affect the performance of supply chain?
The performance of the supply chain, yes, I would say, looking at this slide here, performance may be defined on several aspects and criteria. If it is just efficiency, small delivery times, and so on, then this is just one criteria for such a supply chain. But there are other criteria that are getting much more important. That is the resilience of the supply chain. Most of the producing companies know their first tier supplier, but they do not look behind. And having such crisis as we have today in our mind, you have to look also beyond. You have to know, okay, where does the submaterial come from, and where do the components come from? And also already for very small electronic devices, for example, such as a computer mouse, you see that there are dependencies down to Africa, down to China, and so on, where all the material comes from. Industry 4.0 has an effect upon the performance of the supply chain in the sense that it allows also to flexibilize the supply network and to put performance criteria upon them, and to make also changes in the supply chain much more easier based on such marketplaces such as the Smart Factory Web that I have shown you.
Yeah, thank you, sir. So last question from Bindu Thomas. So what skill sets are required to for Industry 4.0 preparations?
Okay, this is a very good question, and it brings me back to this slide here. Apart from all the technological achievements of Industry 4.0, what has been one of the main benefits is that mechanical engineers work together with electrical engineers and computer scientists and production engineers and even business engineers. So Industry 4.0 is a multidisciplinary approach. You cannot solve these demands as a computer scientist only or as a production engineer only. You need teams. And the best is that these teams are multidiscipline. So you need people from all these disciplines. They have to work together in such environments in an open manner, and they have to understand each other. The mechanical engineer has to learn a lot about IT, and computer scientist has to learn a lot about production. So all skills of all engineering disciplines are welcome. The only requirement that you need an open mind skill. You need to learn from others. You need to work in teams. Maybe this is much more important than to be expert in one of these disciplines.
Okay, thank you, sir. Thank you for your nice session. I would like to thank Dr. Uslander for his nice address and giving the insights about the Industry 4.0 in Germany, as well as what preparations are required, all these things. Sir, we request you again to join us for second session of panel discussion. So it will start at 12:30 CEST. Means in India it is 4 PM or 4 IST. Yeah. Yes, sir.
Okay. I also want to thank you for your kind audience attendance and for your very important questions. You may also contact me after this presentation by email, or
Yes,
I'm also present at LinkedIn. Just join our activity. You're welcome. Thank you very much.
Yeah. Thank you, sir. Thank you very much. Okay, sir. Thank you.
MIT में पढ़कर हम चलते हैं सक्सेस की ओर। MIT Group of Academic and Research Institutions, Aurangabad, Maharashtra, announces admission in engineering and management with 40 years in technical education, over 12,000 plus students, best placement cell in world-class companies, best infrastructure. Bead Bypass, Aurangabad. Call 0240-237-5375 or visit www.mit.asia.